Alright, this is Chapter 2, Section 6. Now we're going to calculate the area under the curve and do actual probability questions. So you have to realize PDF versus CDF we talked about before, which is the probability density function and cumulative density function. There are many PDF and CDF functions. So there's Z, T, F, and chi-squared are the basic four, essentially. So we're specifically doing Z right now. So the PDF is this curve right here, the probability density function, right? This is this curve right here, right? The equation for the specific bell curve or a normal curve, right, was all the way on page 1, right? So this is the equation here. Right. If it's standard normal, it's the same curve, right? So normal versus standard normal, you just replace it with a 0 and a 1, you get this version of it. But either way, it's still the same curve, right? So the PDF function is essentially that curve. If you want the area under the curve, you have to do the cumulative density function, right? You have to accumulate the area. So essentially what you're doing is you're doing the integral, we'll say from A to B, right? From A to B of the function. So that function is on the first page, right? So if you're doing calculus, that's essentially what's happening is you're doing the area of the curve. But the spreadsheet will do the work for us. So it knows the formula for the standard normal curve, and it'll actually do the math for us. We just have to understand that the way the computer works is it calculates area left to right. It doesn't calculate right to left. So it's like you read a book, right? And the reason it does that is because when you do calculus, for those of you who know calculus, that's the way the calculus works, essentially. Okay. Another thing to keep in mind is these normal curves, right? They go to negative infinity to positive infinity. So they do go out forever, you know what I'm saying? And of course, right, the middle of it is, 0 for z, right? Unless it's x, then it's whatever the mean is, essentially, is the middle. So you only have really 3 different variations of problems, essentially, in the next 4 chapters, so chapters 6, 7, 8, and 9. So we're going to do other types of density functions. We'll also do t also. So we're going to do z and t in the next 4 chapters. When you go to Stats 2, they have chi-squared and f also, which is the skewed ones. We're only doing symmetrical ones. The skewed ones will be covered in Stats 2. Okay, so first off, the easiest version of the 3, type 1, which is you either want a positive z-score or negative z-score location, and you want to know the probability or the area. Because again, area and probability are being interchanged. Because if you're doing the actual calculus, it's area under the curve, this being the curve. But the area is probability in statistics class. So if I want to do the area to a positive or negative z-score, left to right, I don't need to do anything special because the function in the spreadsheet does it automatically. So all I have to do is calculate using the given z-score, okay? And because the area is calculated left to right, I don't need to do anything special, okay? However, if I want to go the other way and I want to know more than something, right? The problem is if I calculate the area left to right, it's going to give me the wrong area. It's going to give me the area in this blank space. It's not what I want. But if I do 1 minus, I will get the answer. Because if you think about it, if this is 20% over here, this is 80%, right? If this is 15%, right, then this is 85%, isn't it? Because the whole area is 1. So essentially what you want to do is calculate the area using the z-score, but in this case do 1 minus the given z-value because the area is left to right. They're complementary essentially, right? Because if this is 70, this is 30, right? If this is 60, this is 40, right? It's complementary. That's so you could use the 1 minus rule. Okay. All right. So the first one you don't have to think, just do it. It's pretty straightforward. The second and third one you have to do a little bit of work because this one you have to think about the fact that it's 1 minus because again calculus only works left to right. Okay, and the last one is if you want to find the probability of being between 2 values. And again, as to what these things are, we don't know. These could be heights, these could be IQs, these could be weights. We don't know what these things are. These are just generic cases here. So the thing is, if I calculate the area to this one, that's not the correct area. If I calculate the area to the second one, that's way too much area, isn't it? But that's fine. take the entire area of the bigger one and subtract the area of the lower one, I would get the answer, wouldn't I? And it always works. Take the area of the bigger one, right? Take the area of the bigger one and subtract the area of the lower one, and you will get it, right? Because again, everything works left to right. So, and the words can be interchanged. You can say larger or lower, whatever you're saying, you know what I'm saying? So this is the area that's on, or the z value that's on the right, you know what I'm saying, or the larger value, the one that's on the right versus larger value, or left or smaller, depending on how you want to say it, basically. Okay, so just subtract the left from the right, the smaller from the larger as far as the calculation, and that's what you'll get essentially. Okay, so without having to do calculus, there must be commands in the computer to calculate these things, right? So these are the Excel commands here, right? Notice it says normal because it's the normal curve, right? Okay, so this x can also be z, right? You put in mean and standard deviation and true. Okay, so distribution is the distribution of area. That's what that's saying. Okay, and the question is, why are you putting true? Because it's saying accumulate, because remember there's CDF versus PDF. This gives you the CDF version. So true is saying accumulate all of the area left to right. Because otherwise it's only doing the value here. If you do false, that's not what you want. Okay? In inverse, what the inverse is doing is inverting the area back to a z-score, essentially. So this is a z-score here. So it's a question of, do you want the actual value or do you want the probability? What do you want? So this one gives you the area, or the probability, right? The distribution of the area, or invert the distribution or invert the area back to a probability. That's the two things it does. Okay, so let's open up a spreadsheet here and use the one from before and make a separate tab. Okay, and we'll blow it up a little bit here. Okay, so I want to know the area from left to right, so I don't need to do any extra special work here. So it's normal dot distribution. Right, you can click on it there, and I'm going to do 2.06, which is the z value here, right? Because z is 2.06, so it can be x or z if you look there. Comma 0, comma 1, comma true. Okay, notice it says accumulate, and I'm putting true, right? Okay, so this is z. Since we don't know what the actual data is about, we don't know what this data is about. It could be height, weight, IQ, anything, right? You're going to use the standard normal, which is 0 and 1. So anytime you're doing z, it's 0 and 1 for standard normal, right? And this makes it a CDF, so it's going to calculate all of the area left to right, essentially, right? So we get about 98%, basically. So this is 0.98 ... essentially is what the area under the curve is. That's what it works out to be. Okay? Okay, so that one's straightforward. It's left to right. However, the next one is not going to work out the way we think, because if I do the area left to right, it's going to give me this area, because this is version 2, all right, or type 2, which means I need to do 1 minus this to actually get the correct answer, right? So let's do equals 1 minus normal dot distribution negative 1.14 comma 0 comma 1 comma true. Okay, so I get about 87. Okay, so this is about 87 there. So let's say get rid of this right here, right? I got 12 or 13 basically, right? So 1 minus, so essentially I get about 87 here, correct? Come on, about 87 here, and I got about 13 there, correct? Because if I didn't do the 1 minus, I got that. If I do the 1 minus, I'd get this essentially. Okay, so that's the probability. As to the probability of what, I don't know, because I don't know what this area is representing of the curve, because these are generic problems. Later on, when they represent something, we'll know. Okay, all right. Next two. Let's say we want to do this one here, right? The problem is, this is type 3, isn't it? If I do the area from this one to this one, that's too much. If I do the area from this one to this one, it's the wrong area, right? So I need to subtract the lower one from the upper one, don't I? Okay, so I'm going to do normal dot distribution 1.68 comma 0 comma 1 comma true minus normal dot distribution negative 1.37, comma 0, comma 1, comma true. Okay, so upper minus lower. About 86 is the middle there, essentially. Okay, so that's about 0.86 dot dot dot. Okay, all right, so let's put these here. So we got 1 minus on this one, right? We got 1 minus on this one, and we got the subtraction here. Okay, so let's dictate a point here. So before when we did this, this was a negative z value, right? Negative z value. If I change it to positive z values for either case 1, 2, or 3, does that make some kind of difference because it's negative? No, it doesn't make any difference whatsoever, right? So again, if I do the area left to right, that's going to give me the wrong answer. It's going to be way too much, correct? I need to do 1 minus to get the answer. Okay, so if I do, let's get this out of the way here. There we go. Okay, normal dot distribution, right? 1.1, comma 0, comma 1, comma true. Okay, that's 86, which is obviously this white area. That's not correct, right? So we do 1 minus. Okay, we get about 13.5, which is this area up there. Okay, keep in mind none of these are to scale. I just roughly drew these, so it's definitely not to scale. Plus, that's why the color doesn't always match up, is because depending on when I did it, I didn't always select the same color in the wheel. So, whoops, that's not what I want. Okay, all right. So typically you have questions in terms of probability and statistics. It's area and calculus, which is what the spreadsheet is essentially doing for you without having to know calculus. But you're asking probability questions in statistics, right? So typically using the probability notation. So let's say this is like height, right? Is your height more than 6 feet? Is your height less than 6 feet? Is your height between 5 and 6 feet? I don't know, I'm just making up numbers here, you know what I'm saying? Or a z-score. It's either going to be terms of z-score or actual value. So those are essentially what's going to be asked, right? So you think about it this way. If I do 2.32, that's not going to be the answer for the z. That's too much, right? But this is the other half. This is 0, isn't it? So what you have to remember is the entire area is 1, so this is 0.5, isn't it? Okay. So when I do the spreadsheet, I can do one of two things here. I can do normal dot distribution, and I can do 2.32, comma 0, comma 1, comma true, in minus 0.50, right? That's one way of doing it. Or normal dot distribution, 2.32, comma 0, comma 1, comma true, and then do minus normal dot distribution 0, comma 0, comma 1, comma true, right? Because the z value at the middle is 0, right? Same answer, right? So either way, you're going to get the same answer, correct? Okay. All right, so here, right, if I do 1.91, the problem is that gives me this area, which is not what I want, correct? So I have to invert it to get the complementary. So I'm going to do, whoops, I'm going to do 1 minus normal dot distribution 1.91, comma 0, comma 1, comma true. Okay, so about 2-3%. That makes sense there. And then this one's pretty straightforward, left to right. Normal dot distribution 1.65, comma 0, comma 1, comma true. Okay, about 95%. Okay, so one thing I will mention is notice how every one of my questions here has a nice picture, correct? Okay, the textbooks in my assignments do not have pictures because there's only 3 pictures, right? No matter what the picture is, it's always 3. It's a less than, a greater than, or between. There's only 3 pictures. The picture is not relevant to the answer or the question. Okay, you should be able to picture it in your head as to what's going on, whether they give you z-score or they give you a probability type question, right? You don't need to draw it unless you want to, right? So you need to be able to read the symbolism and figure out, or the values that are given, figure out what's being asked, right? You know, do I want the answer for the things that are above it, less than it, or between it, basically, is essentially what's being asked.